All right, in this wave, we're going to look at the guts of a sound wave. But before that, we do that, we have to think about how we get the sound wave into a computer to depict it. Here's a picture of a sound wave. But as I mentioned in the previous video, sound waves are longitudinal waves. The particles, if the wave is traveling like this, the particles are moving back and forth along that line. They're not moving up and down. So why do we get this up and down depiction? Well, what we're measuring there, remember, the typical device for measuring sound waves is a microphone. Okay, so you can see one back there. Um, most of the microphones we use aren't quite as visual as that. They're little dots in the corners of our phones and whatnot. Uh, but basically, what a microphone is, it's a membrane that responds to pressure differentials. Right, the pressure on one side varies while the pressure on the other side doesn't. If it increases, it pushes that membrane down. If it decreases, it draws, or the higher pressure below pushes the membrane the other way. And as it moves, it can induce an electrical current that then gets recognized by the computer. And that current can increase or decrease, reflecting an increase or decrease in the pressure on one side of that membrane for the microphone. So this depiction represents increases and decreases of pressure. Right? So it's not picturing it's not a picture of sound waves going like this. I'm not very good at that, but sound waves doing that sort of transverse wave thing as it travels. It's a picture of, at the point of the microphone, pressure changing over time. Okay, so we'll go back to that and we'll have a little bit of time, spend a little bit of time with that depiction. Now, this is a simple wave. This is a simple sine wave. We will learn later why we call this a simple wave and what it means to be a complex wave. But let's look at some of the properties of this. Now, first of all, remember the horizontal direction is time and the vertical dimension is pressure. Now, we're going to insert a zero line here. That isn't a property of the wave. It's just that neutral pressure around which the pressure of the sound wave is fluctuating. Right? That'll be whatever the ambient pressure in the room or the space is. And that will change over time, but it changes over a long time. So we can sort of treat it as neutral and static over the period of what we're interested in, the period of looking at our wave. Okay, so what do we have? Once we have this zero line established, we can see that there are points where the wave crosses that zero line going up. We call those positive zero crossings. And there's a couple pointed out here. And conversely, there are negative zero crossings. So there's a lot of zero crossings. Some of them the wave's going up, some of them the wave is going down. All right, another point that we want to notice is a maximum. And in a repeating wave, there are several maxima, points where the wave goes up, it hits a maximum and goes down. So at a maximum, either side of a maximum, the pressure is lower. It's increasing up to the maximum and decreasing after the maximum. And of course, we have minima as well, which is just the lowest points of pressure in the waveform. All right, now we can take the time between two comparable minima, and we notice that this stretch of the wave is repeated over and over again. Okay, so we take one repetition from a minimum to the next corresponding minimum. We have a single cycle. We could also take from one negative crossing to the next negative crossing, positive to positive, maximum to maximum, or halfway between the minimum and the next positive crossing, halfway between the next minimum and its following positive crossing. As long as the start and the end point are corresponding, they represent similar points on respective waves, you have a single cycle. But it's the minima. That's a nice clean landmark to use. And if we look at the time it takes for a single cycle to happen, that's a single period. And we'll be talking about periods more in the next video. Okay, so that's a little bit of anatomy of a simple wave, and keeping in mind that we're talking about the fluctuations in pressure over time when we're looking at these graphs. Uh, Acoustics is a very concrete and physical science, and we have to be very clear about what it is that we're measuring, what we're depicting when we have a graph like that. Any representation really, but particularly a graph that's a couple stages removed from the raw data that's input, that actual sound that gets detected by the microphone. So pressure changes over time, and we've looked at properties like maximum, minimum, the zero crossings, positive zero crossings, and negative zero crossings, and we looked at the period of a single cycle. Okay, more very soon.